Good afternoon to everyone. This is Dr. Polaiah, working as a professor in the Department of IT. And I'm very happy to share our video lecture on histogram processing and its applications. This is the topic which we are covering from our image processing syllabus. Of course, the syllabus which we are so far we have discussed more than 20 videos, but point is here, this one of the topic which connected throughout the image processing syllabus. That means all modules of the syllabus may have the specialization of the concept which we call as histogram. So histogram processing, which we are going to be understand here in terms of defined by the help of histogram equalization. That means your histogram processing 100% obviously you are defined in terms of computer processing technique, which is used to improve the contrast in image. So it accomplished this by effectively spreading out the most frequent intensity values, that is, stretching out the intensity range of the image. In an image processing context, a histogram of an image normally refers to a histogram of the pixel intensity values. This histogram is a graph shows the number of pixels in an image to teach. So based on the different intensity values which we have found in that same image. So once we understand the simple definition about the histogram equalization by the histogram equalization technique, which we are using especially for the of course, we may be concentrating on one of the application, maybe image enhancement. So that means here we are concentrating histogram processing, basically where we are concentrating in terms of image enhancement, which can be done by the obviously which we are proposed histogram technique only, that we call histogram equalization technique. 100% this histogram equalization is a technique for adjusting the image intensities to enhance contrast. So this method usually increases the global contrast of many images, especially when the usable data of the image is represented by close contrast values. So where we are concentrating such an image is help us in terms of for the concentrating of histogram modeling techniques. The best example is here, that is histogram equalization technique, which provide a sophisticated method for modifying the dynamic range of your particular image, and as well as the contrast of an image which we are concentrating by alternating that image such that its intensity histogram has a desired shape. So we understand that histogram processing is the one of the specialized concept where we can concentrate any type of image which can be modified in terms of global image contrast modifications. So for example, you take this image which we are considering here is one of the images which example we are taking here is one comparison in between new and old. So for understand here it is the name of the image which I named as a new image. The name of the image which I named as a old image. Okay. So why we want to find why we want to keep this image names as new name, new image or old image? In this sense, I'm finding that equalization of the intensity values which are vary in the particular image which I named as a new image. And also we are concentrating one more image which we call as old image. There also we are concentrating by the help of one of the histogram method that we call as old histogram processing. So of course here we are saying is new histogram and old histogram. That means the corresponding image of new image is the new histogram equalization. and old image equalization is old histogram values. So what we find here, we are keeping the value of the pixels on x-axis. The pixels of the values are on x-axis, which varying in terms of intensity. So where we are varying the pixels of the intensity, pixels and its intensity relations varies, shows us whether we want to increase the intensity values. That means you want to change any intensity values. That means the contrast of an image which we consider as a new image need to be improved or not. How you may be knowing that? In the sense, by the finding of histogram equalization value, which we are keeping in terms of understanding a particular image equalization of characteristics values in the relationship of pixel and its intensity. So, based on these values variations and understanding of in terms of pixel relations by the see in terms of visibility of characteristics, we conclude and we are started and applied the histogram equalization method, which we want to improve the contrast. See here, your contrast is right now improving. Your contrast is right now improving in terms of where you are going to be enhanced. So here the enhancement will be happen. Enhancement will be happen whenever you are taking this. Whenever you are taking consideration in terms of contrast only. So by seeing this slide information, we consider a image which is named as a new image and old image. Based on applying of this, what we called histogram equalization method, we right now concentrated which image has been improved the contrast, or which image has been enhanced in terms of your required manner. So that we are concentrated about to understand the concept of histogram processing. Once we understood this, so there we are concentrating being a technocrat, being a budding engineer, we are concentrated to prepare a program, computerization program, by the giving of importance in terms of proposed method, the named as histogram equalization method. It is a computer image processing technique used to improve the contrast in any globalized image. So it accomplishes this by effectively spreading out the most frequent intensity values, that is stretching out the intensity range of the image. So your image which we are keeping in terms of either 2D image or 3D image based on x-axis values, we call as a pixels, and where we are keeping on y-axis as intensity values. That means in your image which you are keeping into transformation of your required formation in terms of pixel intensity values. So that means your image which we are considering in terms of matrix values, which by m by n matrix values. These pixels of the intensity values are vary, which we are understandable based on by applying the equalization method. So the method which you are applying here is obviously you are giving the more importance in terms of improve the contrast of an image. Simply we say that image enhancement or image enhancement, and it's stored based on your required processing. The meaning of required processing is here towards to apply the certain steps. What are the steps we are using here? So how your histogram equalization used in the image, we can understand by following the coming steps. Steps involved in applying your method, your proposed method. What is the name of the method? Here is called histogram equalization method. So what is step number 1? Get the input image. Of course, you may be acquire an image which you are captured from the or by using the digital camera. No doubt about it. That is one point. That is a step number 1. Step number 2, once you acquired an image as input image to for the sake of applying of your method, here step number 2, generate the histogram for the same image which you are considered as an input image to the proposed method. And we are going to use step number 3. We are finding the characteristics of the image which we are in terms of histogram equalization, which we are called in terms of characteristics of same image, is named as local minima of the same image. So based on this local minima or global minima values, which will help us to find out the intensity variations in the characteristics, which we can see physical visibility. So once step number 3 is over, then immediately we are going to be apply the step number 4. What is step number 4 is divide the histogram based on the local minimum value, and then we apply the step number 5. What is step number 5 is have the specific grade levels for each partition of the histogram or not. So we are going to be see that have the specific grade levels for each partition of the histogram is we are concentrating. The meaning of grade levels are here is the image which we are considering in terms of black and white image. So the range of image which we are considering, here is obviously 0 to 255 pixels variation with respect to or by the variation of the intensity of the same pixels. So once we understand such a image, either 2D image or 3D image, then we apply the histogram equalization on each partition of the your considerable image. So once we applied the step number 5 and 6, then immediately we are go to the your required histogram equalization image, which we discussed in with the help of previous slide. Of course, once we understand these 6 steps which are involved perfectly for converting your required image into expected enhancement of an image, we'll apply and see the by the help of histogram equivalent method. But here you are going to concentrate given that enhancement of an image it can be enhanced in terms of not only in a fixed manner, but also it may be vary by the help of histogram equivalent, which we are keeping in terms of classification into different types based on the frequency distribution of the image data. So that means the different types of histogram where we can apply here is in terms of your required processing of histogram processing on your selected image. So what are those different types of histogram processing are: number 1, uniform histogram; number 2, symmetric histogram; number 3, bimodal histogram; and number 4, probability histogram. So by using this all 4 different types of histogram, we may going to be concentrate to prepare your histogram equivalent image, which we keeping on to apply for the required applications. Yet we are going to be see that what are those applications which we can be concentrating are here. So the applications are here is in digital image processing. Obviously, where we are concentrating such a histograms are used for simple calculation in software method, but it is used to analyze an image equivalent pixels of the intensity values also. But where we are concentrating such variations of the pixels of intensity in terms of properties of an image can be predicted by detailed study of the histogram, So this is one of the application which can be applied based on your required manner. That is, the required manner in the sense your image want to increase the brightness of a particular image in terms of scale in terms of scale eligibility way. The meaning of scale eligibility is nothing but adjusted value. So brightness of an image can be adjusted by having details of histogram processing. So we have, that means the histogram processing is here we consider as 100% what we call user-friendly processing, because histogram equivalent method which we are considered under the histogram processing is the one computerized technical process only. Computerized method, I can say that computerized method. When we are consider a computerized method, it is very easy to implement according to your willing, according to your friendly preparing of the code. That means we can say software processing. So that is, we can say software processing. That is what we can understand here. So, and coming to the another important point is here. So far we discussed that histogram processing is the processing which we consider in terms of histogram equalization, is a technique for adjusting the image intensity to enhance contrast. Of course, we concentrate that, but how you maybe enhance such contrast? We're going to be define such equalization, such a histogram equalization will be going to be prepared in a simple mathematical model which we consider under the considered image of object function defined in terms of f. So simply we say that let f be a given image representation as your range of in terms of either number or by MC matrix of integer pixel intensity ranging from 0 to L minus 1, where L is your gray level. What is the L? Your gray level image. Your gray level image range. Gray level image range. What is this range? It may be vary in between 0 to 255 values. That is, max it varies 256 values only. So that means it is the range of L which we are going to define max 256 values only. How these number possible intensity values oftenly keep 256 in the sense it is the basic information or fundamental information about an image which we are considered in terms of gray. Once we understood this, what we call histogram equalization, which we have proceed as a method by the help of consider image of objective function, and it help us to prepare such a image. Minimum, little bit processing is here by the consideration of relation in between x and y values. The x-axis values which we are internally under which the measurement falls is shown in the x-axis intervals, where we consider this x-axis intervals, intervals which are considered in terms of pixel values, and where we are consider y-axis also, where we are preparing your pixel intensity values or the values that occurred within the interval set by the x-axis is shown in the y-axis values. So x-axis and y values are vary only in terms of your image which you are consider in terms of pixels and its intensity values. So once we understood such a simple processing, let you going to have one more important point is here. A image of histogram we are keeping in terms of graph, means that is characteristics of particular image. We are going to be used in terms of the bars. The bars are used for showing the value of your particular or required data. Okay, the data is here in terms of pixels and intensity values only, P and I. So such a values we are proceeding in terms of an image histogram is a graph pixel intensity on the x-axis and versus number of pixels on the y-axis. Here only pixels will come. Here only pixel intensity will come. Intensities are varies on the y-axis. Here pixels value. So by the relationship of these two values which we are consider here is we are keeping on the here. Here it is simply pixel intensity. It is pixel intensity. It is pixel. Here is pixel. Here is pixel intensity. Here is pixel intensity. Okay. Once you understand that various, so we are going to keeping on the gray levels variations. So which indicates the number of pixels that have particular gray level variation. So when we keeping on to changes, such a gray level values vary in terms of your required manner of an image concentrate as a parts of histogram. So once we understood a simple method which we call as image processing, that image processing we extended one of the method which named as histogram equivalent, or histogram equivalent is a computerized technique process as a software tool where we can apply towards to convert an image into enhancement image, or we can understand the darkness or the brightness of an image which we are understandable by the applying of such a simple principle of histogram processing. So here once we understood such a concept, yet we also going to concentrate one more important point of this histogram processing of advantages and disadvantages of histogram processing is here. When we consider advantage point of view, a histogram cannot be used to represent discrete frequency distributions, but it can only be used to represent continuous frequency distribution, because we are seeing that the complete image which we are consider here, this image we are keeping in terms of characteristics of such a image only in terms of axis which vary in terms of continuously variation. Such a continuously variation of characteristics obviously we are going to use in terms of continuous frequency distributions point of view only. But where also we are understanding such a histogram processing in terms of a disadvantages of histogram compared to a box plot is that box plot gives us extra information such as the median filter processing or upper quartile and the lower quartile of the data processing. So such a processing is taking much more lengthy processing. Histogram equivalentization, very lengthy. It may feel sometimes what happen, maybe disturb your expected enhancement of an image, or contrast point of view. If you want to extend, it is also disturbed. That's what we are considering here. Such a processing 100%. We may have a little bit complexity. That's what the disadvantage is here. Will not be considered. Sometimes the extra information such as median value or upper quartile and the lower quartile of the data processing will be changes, obvious. For example, I'm going to have some more what we called based on the advantages and the disadvantages. Let me to show the some what we called image processing in terms of applying the histogram equalization. We have this image, wonderful image, which we copied from, of course, internet point of view, and we found the histogram equalization is here corresponding and equivalent to histogram. We are finding such a value, and we see that the input which we are keeping on to changes here is some non-linearity, that is S curve is coming in the sense it is having the not responsible, not in the understandable histogram processor. Now after we apply the histogram equalization method as a computerized method by the help of any software tool, we can convert that into S curve is converted into linear curve now. So what do you mean to understand from S curve to linear curve is here, your required equalization is reached right now. So here histogram is very complex. It is here very complex values which are not be understandable. But here obviously 100% understandable values. understandable values. So such a corresponding histogram, red color cumulative histogram as a black color, we may see this both in terms of understandable way, in terms of your equalization of the histogram equalization. Before equalization, you got this. Cumulative histogram is not understandable. It is complex. After histogram equalization, you got very clear and readable information. That is what histogram processing had very good advantage, which can be applied for the achievement of your enhancement. So, for example, let me to take other type of images which we can understand from here also. Original image is here. After your applied histogram equalization, we compare both histogram, original histogram of the equalization of particular original image, and as well as a particular what we call equalization of the original image. So we find here both the intensity levels of at x-axis and pixels of the intensity values at the y-axis, whereas in for the grayscale image it is very easy and understandable with respect to their respective histogram values. Okay, so that is the one more example which we can understand from here. Right, next I wanted to extend this histogram processing which we want to implement for the sake of different types of application. So for that implementation, we simply follow a simple diagram, sample block diagram. It is the sample block diagram. Understandable? Sample block diagram. This figure is considered under the sample block diagram. So this sample block diagram help us towards to implement of histogram processing by the apply of histogram equalization. Simply we read the image in terms of pixels, obviously, and get image size in the required image size. That is in terms of pre-processing. Pre-processing will be there. Pre-processing will be there, and get your histogram values. Okay, that is get in terms of your cumulative distributed of the frequency value, and then we are going to calculate such a histogram equalization values. Once you calculated histogram values, then you are applied the brightness values to the mean scale values. Then finally you will get your resultant information, your expected resultant image data. So such a processing which we consider towards to improve your histogram equalization by the applied of histogram equivalent method. So next here also the histogram equalization processing is right now concentrating one of the function that we call as a CDF function. That is cumulative. That is cumulative distribution function. It is a distribution function. Okay. Such a distribution function calculates the cumulative probability of the given x-axis values, which are used to finding in terms of CDF to determine the probability that a random observation it is shown taken from the population will be less than or equivalent to a certain value process. So with this, what we understand based on your applied such a block diagram, simple block diagram, we proceed to extend such a mathematical processing is here considered in terms of your discrete function. So what is your histogram in digital images is defined as a discrete function is h of rk equal to nk. What is the rk? Is the gray level of a kth, and nk is the number of pixels that the values which we consider as an input to the histogram equalization. Before we apply this mathematical principle, simply we can also apply the normalization process for the understanding or for the improvement of performance of a particular histogram processing. So that means performed by the dividing each value by total number of pixels in the image, we'll get simply the probability of your PR of k, that is gray level of k instant, will get nk by n. So what is your estimate of the probability of occurrence of a particular grade levels of the RK is your P of RK. That is the probability value. When we consider such a components of the normalization histogram, we are going to make it equivalent to 1 or 0. 1 or 0 when you are keeping on in the normalization 1 or 0 is 1 is set to 1 means you are applying the your histogram processing for the sake of your expected image enhancement. So once you got it that simple mathematical histogram processing method, we can concentrate here one by another. Here dark image histogram we can calculate, brightness image you can calculate, and low contrast, high contrast histogram we can be calculated by the help of n or k with respect to n number of pixels. So once we are using such a equalization of mathematical analysis of the image, which we are applying in terms of digital, so you are going to be convert your required manner of dark image and brightness image. Once you achieve this histogram is more useful in terms of improvement of your contrast, in terms of contrast of an image. So this is in the contrast of high contrast or low contrast of histogram based on your referred from our reference textbook. I may be showing this reference textbook is here. Of course, you are all understood our simple concept of histogram processing and its method named as histogram equivalent method. It is also called as computerized method, which we are going to be keep on to calculate your cumulative values not only in continuation domain but also we also apply this histogram for digital images also. Of course, both we are comparing and understandable in terms of improvement of your enhancement of an image and readable way. So I hope you are understandable all this point by another point for sake of simple definition of an image and image based enhancement by the help of histogram processing. I'm very thankful for your complete understandable this in a simple definition. Thank you so much. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.